Good afternoon, everybody.
Good afternoon, sir.
Thank you, Afritex, for giving us this adjustable mic. Usually they are taller than me, and then I have to be fighting over it. This is not going to be a PowerPoint presentation. We're not going to spend time looking at the screens. We're just going to try to find practical ways of solving the problems and identifying solutions for them. So we're going to make this as interactive as possible. My name is actually Ofor Aligwekwe. It's an Igbo name, 100%. And the company name is Green Gold Energy. So we're a renewable energy firm, and we integrate solutions, vertical solutions across industries. Quickly from the title, the beauty of the title or the topic that we have says powering cellular networks. So we already know what we want to do, and then it says renewable energy. So the solution set is kind of already identified and narrowed down for us. All over the country, if you look around, you're going to see solar projects, solar street lights. You're going to see people that have inverters. You're going to see different types of solar applications. So I'm not going to spend a lot of time discussing or describing what a solar panel is. If you have any questions, feel free to ask. What I'm going to do right away is to go into the reasons we should consider using solar solutions. One, to power our cellular networks, and then two, try to get some information from the audience on what are the challenges you faced in trying to implement power solutions for cellular networks, and if not cellular networks, other kinds of scenarios that you might have. And then based on those identified challenges and problems, we go straight into what recommended solutions are and how you can go about implementing a successful solution, the key success factors in this case. As much as possible, we are going to be vendor independent. The reason we have some products that we offer here is just to show you what some of the products might look like in case the questions come up. The idea is not to sell any of those. If you give me business, I'll love it, but then, that's not why we're doing this. Okay, good. One, like most of the speakers have said here, the operational cost of running a business in Nigeria is very high. One of the things that is highest, the most, topmost on a small business or in telecoms is the cost of generating your own electricity. From our military men who are somewhere in Maiduguri or out there fighting with insurgents or Boko Haram as it may be, they carry power generators, and the diesel and petrol generators, and they carry either petrol or diesel. When they run out of it in the middle of the bush and their supply line is cut off, they lose command and control completely, because they wouldn't have the ability to be able to charge their walkie-talkies or communication devices. Then we bring it down to ourselves in our places of residence, and then bring it to the telecoms companies. For telecoms companies and operators, the cost of being able to power a base station, which is all those towers, masts you see, that has their radios, their multiplexers, their antennas, is high. Sometimes where you see, like if you look around the city, places where you see the masts, you see small houses there, like containerized houses or things they build where they put in air conditioning systems, they put in massive generators, and they will even have a diesel tank and then have people doing that routinely. When you travel from here to the United States or London and you're like, wow, in this place the service is so good, the network is never dropping and everything, those people can afford to put massive equipment in a point on a mast that will have the capacity to carry the desired load without worrying about providing themselves, for instance, the backbone fiber, like we've just been told, or worrying about how to power the equipment they are putting on the mast. So in the case of Nigeria, the benefits in using renewable energy is that when you're using solar products, solar powered products as a means of powering either your homes, telecoms equipment, your military gadgets, medical facilities, educational institutions, you almost have like just your cost of ownership. Normally when you're looking at the cost of money you spend in a quick piece of equipment, most people will tell you about TCO, total cost of ownership. They're looking at the cost of acquisition, buying something like buying your car, and then the cost of using it, the cost of running it. When you have a generator for a telecoms company that is in my village, which is very far from here, or somewhere in Boronu, or somewhere in remote part of Ondo State, they have to find a way of always paying manpower to drive petrol and diesel to the place, just like you buy. If you're using solar, that is cut off completely, because when you're using a solution like that, you will not need petrol or you will not need diesel. Now, I'll jump straight into what are the pitfalls implementing projects of that nature. And in looking at that, I'll tell you the same reasons that you see a solar power street light on the highway, or I wouldn't, if I say solar power street light on the highway that is not working, it might not be correct because most of them don't work all the time, like you see on the streets here. So some kind of thing that is meant to be a street lighting that is solar powered and they are not functioning is the same challenges they have, the same pitfalls that you have is exactly what you're going to have when you're powering your masts, when you're powering your houses. In fact, the masts that you power with the equipment and radio will normally have, on the average, just about the power you need for someone that is in a very small apartment that just wants to power his fridge, 1 or 2 air conditioners, like in a 3-bedroom, and his other electronic appliances. What are those pitfalls? 1, the components required for you to be able to do a solar project, and if you're going to power equipment that is using grid electricity, in this case AC, in this case something that is running on your 220 volts, you're going to need 1, your solar panel. After your solar panel, you're going to need at the bottom your battery. Now, the battery becomes optional depending on what you want to do. And I'll tell you why. Your solar panel's job is simple. Take the energy from the sun in terms of the light. It's good to have warm temperatures, but not hot. As the temperature gets too high, your solar panel performance drops too. So it takes the energy from the sun and it converts it to electrical energy, and that electrical energy has to go somewhere. It's either it's powering an appliance immediately, or you're storing it for later use. At night, the sun disappears, so your solar panel will stop generating electrical energy. So in the case, for instance, of your house or for your mast, you need a battery at the end, because the battery has to store the energy your telecoms equipment will use at night, because we make phone calls at night, right? Beautiful. Now, However, if you're implementing a solution whereby you do not need power at night, for instance, it's a pump, like a water pump, you might find people making costs that are high because they are putting batteries. If you're powering something like a water pump in your house, and you have the right size of water tank that can serve your family or any of your uses at night, you don't need to spend money buying the battery, because you pump during the day and you consume during the night. Now good. So let's go back to a telecom scenario. The other components that we require in the chain between your solar panel and your battery and the load, which is what you want to power. In this case, we'll call it a base station for a telecoms company that you want to power, will be pieces of equipment that helps you manage the electricity that is generated, one, and also pieces of equipment that can help you reconvert the electrical current, electrical power that's coming from the solar panel or from the battery in a form that your equipment can use it. So the first thing you're likely going to have after your solar panel and in the case where you're having a battery will be your charge controller. Now, for your charge controller, the purpose of your charge controller is very simple, and what it does is to control charging, and that's why it's called a charge controller. And what are you charging? The battery. The process of storing the power from the solar panel on the battery is called charging. Charging your batteries, just like you charge your car batteries with your alternator. So what the charge controller does is it's just an intelligent device that does two things. One, it ensures that the rate at which the battery is charged is not a rate that will damage the battery. One, that's what you look out for in a good charge controller. Two, it ensures that in the time when your solar panel is not generating electricity, for instance at night, that the battery does not lose power, because the way it works is the battery is permanently connected, and what happens is when you're not charging it from the solar panel at night, the power will start coming the other way since it's not coming this way, so you lose. So it manages that, and so that's what you look for in a good charge controller. Now you have to be very careful about something. When you're in this part of the world, you hear a lot of people. Like I went to have a meeting with chief executive of a state, and someone that was there, immediately I walked in, the first thing he says is, "Are your panels monocrystalline or polycrystalline?" And I said, in our region, that is not the issue. So when it comes to your charge controller, you're probably going to find somebody who's going to be telling you, "I need an MPPT charge controller, multi-power point tracking charge controller." Actually, MPPT is a wonderful technology, and what does the technology do? The technology allows your charge controller to optimize the charge rate of your solar panel. Every solar panel, because it's an electrical device, has how it works, the voltage at which it works. That voltage at which you normally connect it to your device will normally standardize. They are not like midway. You normally have to do them according to your battery and some other things. So you might have a 12 volt, 24 volt, 48 volt. But if you're buying a solar panel that is just working with your batteries at 12 volts, maybe it's for best performance is at 17 volts. Which is not what your battery and the rest of your appliances are. So when you're told that this is a 100-watt solar panel and it can do this magic and charge this thing in 1 hour, all that is done at 17 volts. But in reality, when you connect, you're probably connecting at 12 volts. So you find out that the reality is not really the same thing as what you have as theoretical. And so what happens? You put an MPPT charge controller. That's something that has that functionality, and all it does is simulate the voltages that is sent to the solar panel to make it assume that actually this is a 17 volt operation, then it will deliver more power. Right? Having said that, in Nigeria, in West Africa, you don't have to spend top dollar buying that too. We have it, but it's not required. It's not part of the reasons the projects don't work. Why don't you have to spend money buying that if it has such a wonderful role to play? The reason is the way the technology works. At certain temperatures, it cannot simulate that. It cannot perform that simulation. If you are in Canada, where majority of our products and our parent company originally is from, they have a lot of winter. In London, the weather is cold. And so it ups the temperature a little. That's one of the ways it simulates it. And when it warms it up from the other end, it makes it deliver a little more current. In Nigeria, the temperature, the sun is already high. If the people in London were here in summer, they will be in their underwear walking around. So also is your solar panel. So you have to be careful when you're buying as a government or an individual, paying 1.5 times the cost on a functionality that is not required. That's not what causes the problem. Then the other component that will go, without turning this into a classroom, will be your inverter. And so your inverter, all your inverter is doing is basically saying, look, you took power from the sun, use your solar panel to pick it up, you deliver the electricity, you put your charge controller in between to make sure that the rate at which it's delivering is not going to damage your batteries. You run the wires to your battery. And now you're taking the wires from your battery and you want to plug it into your equipment in your telecoms mast or in your house. But your equipment, some of them are operating at DC and some of them are operating at AC. DC is direct current, which is similar to your 12 volt low voltages. But when you want to power something like your television or some other heavy equipment in a telecoms installation, in that case you need an inverter to convert it from the small voltage of a battery and make it, we're talking layman's terms, make your device think that the power is not coming from a battery, from a layman's perspective, that the power is coming off the wall from your PHCN. That's what the job of the inverter does. Right? So now we know the components, we know our load and everything. So why do these things fail? And what are the things we'll consider when we're implementing a project for telecoms or for any other application? One, a lot of the products that are in the market are substandard. So I'll first give the reasons. The first few reasons I'll give will be related to government, because this is also a government-sponsored thing. So they can help us with the regulatory authorities. We don't have a lot of control in terms of standards and specifications of what comes into the country. So you find, for instance, when you buy a street light with LED light bulbs, what you might find, if in this case, if you're using the LEDs to reduce the power consumption for perimeter lighting for your telecoms company, you might just find that after 3 months or 6 months, a product that should last you, in this case, 10 to 15 years, will last you 3 to 6 months or 1 year. That is because a product that is specified, if it's LED, that is specified to be a 50 watt LED light bulb, actually the LED cells on it only have 2 of 3 watts each out of 50 that are authentic, 1 or 2 more of 5 watts each, and the rest of the things that should be over 20 or 30 watts in it actually mirrors with reflectors. You can't detect that when you buy it until you take a high power resolution camera and take a picture of it at night when it's on. Then you see that most of it is reflectors. So when you're buying products, the major challenge you have, a lot of the things that you see government has implemented and people are implementing that is not working, products are substandard. So how do we go about, since we can't control that, as a private sector individual, as a telecoms company, how do you go about ensuring as an individual in your house that you get products that are not substandard, that can meet your needs at a reasonable cost? The first thing you're going to look out for is your battery. The first thing you look out for when you look at the battery that is recommended for you is, does my battery have screws on the top or places from the top that you can open it? If it doesn't have from the top, is there a way that you can actually open it from the sides? Or is there a plastic covering something on top that when you open it, it will look like the old car batteries that we had in those days? Those are lead acid batteries or lead acid batteries, depending on the accent you prefer. And so lead acid batteries do work. They power our cars. The difference with those batteries is they give you massive power in a very short time. So lots of street lights that you see that don't work, lots of home power projects and projects for telecoms companies that are not working, the first place you're likely to look that is a failure is in the batteries. And what I've found most of the time is lead acid batteries. What is wrong with lead acid batteries and what kind of batteries should we use? When you're looking at batteries, you have to first consider outside, this is just for us understanding, not what you do when you're buying or when you're implementing. The first thing you have to consider is, what are you actually trying to power and how is it powered? A massive battery that will power a tractor, a trailer, a heavy equipment, an aircraft engine might not be able to carry your 5 light bulbs and your 1 radio in a telecoms device for 6 months. After 1 month, it will die. The reason is, a lot of your lead acid batteries and the batteries that are designed for vehicles and cars are built in such a way that they can give you a massive burst of power in a few seconds. So if you go overseas and you look online and you're buying them, they'll be measured in cranking amps. That's the sound your engine makes when you start it in a crank. So in a few seconds it will deliver a burst of power. But if you remember your car or your alternator, immediately your car starts, the battery stops working. The alternator will charge it and your battery is sleeping till the next time you start your car. So they are big, powerful batteries. But you know what? They are designed to function maybe 5 times or 10 times a day. Or even if it's 20 times a day, if it's being used for a taxi or something. But in each instance, it's working for just a few seconds. And it delivers massive power. If you use such a battery and go remove all the big telecoms equipment on your mast and even put just one of those light bulbs and hook it up and turn it on, that thing is not going to take a massive burst of power like your engine. It's going to take it's like punishment for the battery. It's wickedness. It's going to take a little amount of power and it's going to take it for 8 hours through the night, 24 hours for the whole day. And the battery will die because it doesn't have the stamina. It's not built in layman's terms to have the stamina to operate for that long. There's a high-speed sprinter. The batteries that are deep cycle that allow you or have the stamina to operate in that way, actually, when you go to market, cost about twice or 2.5 times the cost of your lead acid battery, the one that is used for your car. So most times when people quote for projects, for telecoms projects, for street lights, for homes, for inverters, they give you a pricing that is cheap so that you can afford to buy. You might even be able to buy it if it's higher. It's just that the thing is about making the sale first. And so you end up using a battery. Five more minutes. Fantastic. You end up using a battery that is not going to last you the mileage. So the first pitfall is the battery. The next place that you're going to have a challenge is a lot of peripheral components that you use when you build these things. A lot of solar installations, including some samples done by telecoms companies that I've seen in the country. Please, excuse me, just do that when it's time, please. Yeah. A lot of solar installations that I've seen, what ends up happening is they do not put, for instance, circuit breakers. They don't put fuses, just things that cost $1, $2, timers that should ensure that your installation at home or in a telecoms company is intelligent and sensitive to its operating environment. And in the absence of those, the quality of the installation drops and the failure rate becomes high. The purpose of this short presentation without the PowerPoint is to make it non-academic, to be able to create interest, to make you understand that this is practical and it can be done successfully, and to create opportunity for you to make inquiries. Thank you. No, she was going to ask a question.
We're going to have a question and answer time. I was just going to say you should remain.
Okay.
Okay, questions?
Huh?
The products.
Yeah.
Okay. Can you tell us what it's about in 5 minutes? Thank you.
And so, what we have here, this is. What you have here actually is an integrated solar power generator and inverter. In here, this one that you're seeing, for instance, inside here has built-in 200 amp hour deep cycle batteries. And when I mean deep cycle, I mean that the batteries, you can consume up to 70 to 80% of them. To make it quick, to just quickly rush on the deep cycle thing. A lot of you have, I don't know how many of you, but some of you might have heard someone who bought a battery for his cell phone after the original one died. When you bought the battery and you charge it, immediately you buy it after, it works for you very well. After 3 months, you charge it and it will charge in 30 minutes instead of the normal 1 hour, or even 15 minutes. But if you use it for 20 minutes, it will die. Then you plug it in. Before you go in and come out, it's fully charged. It's called, what happens is when those batteries are not deep cycle, the fake one that you got, but they function. So what happens to them is every time, if you use a battery that is not a deep cycle battery, let's say they tell you what you need is a battery of 100 amps and they sell it to you. Every time you use it in your house and consume the power to almost that it finishes, some of the cells under die. So by the time you use it 3 months, if the original capacity you bought was 100 amps, the capacity you have functioning, operational, will become 80 amps. The cells up to 20 amps is dead. So when you charge it, instead of charging in 2 hours that you would have taken, it will now charge maybe in 1 hour, 30 minutes. And then you go again and use it. In this case, remember it's originally designed for you not to go up to 100. And you went and used 80. This time, after 3 months, the capacity will be 60 left. So this one is integrated solar inverter. It allows you to be able to plug in external solar panels there, external batteries, and in the case that that's for expansion or scalability. In the case that you don't want to expand, to just use it as the way it is. As it is, this will be able to power. Like if we're in this hall, and I don't know, I wouldn't want to just mention, from what I'm seeing here, these are low energy or some bulbs that are about 45 watts and they are many, but for a typical residence in a 3-bedroom flat or in a duplex, this will carry all your lights. My assumption is you're probably using a 20 watt low energy bulb on a 3-bedroom, about 20 bulbs times the 25 watts. If you're using, for instance,
a bulb like that. This is an LED, authentic LED 9-watt bulb. It has the same brightness and luminosity as your 45 watts low energy. And so this here is a different one. This is called an intelligent smart power manager. It's similar to your inverter, but it also takes a solar panel. This is actually, this thing you're seeing is an award. It won the product for Inverter Technology Award and Generator for 2015. It has double the capacity of this one. It scales up, this is 500 watts, but it goes up to 2.5 kilowatts without changing in size. It's just that because it's newer technology, is miniaturized. And then this is something that you normally do, assuming you were doing a hotel or a major project. This is where all your fuses and if you're integrating your grid, like PAC and NEPA, it goes in here, your generator goes in here, everything, and it automatically handles it with the rest of the devices. Most projects that they do, they try to ignore this and wire it manually, and then the things burn up, right? And this is called your combiner box. It will be rare for you to see anyone selling inverter or any of those that has a combiner box in Nigeria. They are selling. The reason is because you can actually use your hands and wire this. But what happens is these are meant to be intelligent devices that protect your investment. So if your technology people look at it as a bank or a company that invests in $1 million of buying banking software and equipment and refuses to put $3,000 to train the staff that will manage it. That's what that does. Any other questions, please?
Any other questions? We'll take the last one. Your name, sir.
My name is Bestman. You are aware that solar panel, money invested upon it is wasted right now in the country. You know that from Port Harcourt to Maiduguri and to Lagos, you have a data specification for panels because of the geographical zones and vegetation in Nigeria. Because what is happening that you are just using one solar panel specification for the entire country, which is not so. Say like in Dubai, they didn't put solar panels because of the sand domes on panels or effects of the panel. So how will that affect people in Maiduguri? You have an R&D that is available to the manufacturers, or you just tell them produce solar panel and send to Nigeria. And why is the cost between China and Japan different on solar panels?
Thank you, Mr. Ofor. Over to you. 2 minutes. Thank you.
Thank you very much, sir. Yes, we have lots of projects that have failed around the country, but we also have projects that are successful. Usually, the projects that are successful, you will normally find in private homes and residences. The ones that have failed, you normally find, unfortunately, with the government. Because for the private homes, when you give a specification and say, this is what is going to work and this is what will protect your investment for the next 15 years, they pay for it and they buy it. Unfortunately, in government projects, they can pay 3 times even the cost of a good one, but will rather get the ones that don't work. However, it's not in all government situations and scenarios. I was in Maiduguri about 6 or 7 weeks ago for an assessment on a team that went to look at what was happening for the victims of the Northeast. And there are lots of projects with solar panels that are working. In Dubai, they are also making use of solar panels. I'm coming. There is infrastructure already built, and so sometimes organizations are not changing them. So you have if you look at the new developments that are actually being built in Dubai, Google some of the new developments that are going on in Dubai, you're going to find out they are building smart homes. There's a smart city that they are building in Dubai, that in that smart city is not even meant to be on the grid. The complete city, sub-city, is a model city for the world that Dubai is trying to put in. 2. One is going to be underwater and one is going to be above ground. They're going to be powered by solar. Having said that, yes, you asked a very good question, and you mentioned something, which is, do we have a specification for Nigeria? Nigeria has its own weather conditions like every other place in the world. And if you look at Ghana, which is not far from Nigeria, they're using solar panels and it's working. And you look at Ivory Coast, it works. So yeah, there are specifications based on your weather conditions. The first thing you normally look at is the isolation, which is the sun. For West Africa, we at least have, on most cases, in this part of Nigeria, about 5 hours in the worst case, unless it's a very rainy day, at least in summertime, of sunlight. In Maiduguri, sometimes it's cloudy. There are specifications. There are specifications. And usually, when you're doing specification, that's where the expertise comes in. When you're implementing a solar project, I'll tell you some things quickly that help you be able to size accurately, sir. One thing you have to make an allowance for is losses from your solar panel as a result of rainy or cloudy days. If you were in Nigeria, based on our weather, the first thing that you can try to do is to multiply it by at least 1.5. So if you're going to use 1 watt capacity, you make it 1.5 watts. You also have to make allowances for losses from your battery. There are several other losses you can make, but we cannot turn this into exact things. The only thing I'll say to you that you have to remember is, it's not easy without connecting a load to measure the wattage of a solar panel. A lot of the solar panels you see in Nigeria, they are using for government projects. The thing on top of it, if you saw a solar panel, the things inside it are not photovoltaic cells. A lot of them is glass that is shiny. So you can actually get 2 solar panels that are 100 watts, or 3 solar panels that are meant to be 100 watts. One is 70 watt or 50 watts, pure glass. The other 2 are 100 watts. But the 2 that are 100 watts are also not good. One is good. One that is 100 watts has an operating current of 4.5. The other one that is 100 watts, listen carefully, the other one that is 100 watts has an operating current of 6 or 7.0. The operating current and not the wattage of the solar panel is an important indicator, because the operating current determines the rate at which your solar panel can deliver current to your battery. Most people that buy panels, even in government projects, specify a solar panel wattage, but they do not specify the operating current. So if you're buying for your house, if you want to buy from someone and they bring you a solar panel, take a meter. Both of them might be 100 watts. If you put your load, they are 100 watts. But how do you know an authentic 100 watts and a fake 100 watt one? When you measure the operating current, the operating current should be very low, and there are standard charts for the minimum operating current for a certain wattage. I can give you a solar panel spec sheet, sir, and you see the different, if it's 100 watts, it should be at least this operating current. Operating current is similar to the speed of your vehicle. So that means you can buy 2 cars. If you want to do transportation, you can buy 1 car and another car. If somebody wants to do a business that should carry people from here to Port Harcourt, Kaduna 3 times a day and back, one person can go and buy a sports car and the other buys a lorry. The lorry is big and massive with a big engine, but the other person will be able to deliver people to Kaduna 5 times when the lorry will do 1. Operating current is what you can measure, and that's what will help you distinguish an authentic panel that is low quality from an authentic panel that is high quality.
Thank you very much, sir.
China and Japan. What happened to them?
Thank you very much, sir. Thank you so much. A round of applause for him. Mr. Ofor, thank you so much. We have a commentator there.
Yeah, I'll just answer your question, sir. I'm a practitioner, an integrator of solar energy, and we've done projects across Nigeria, particularly, and it's a very important question you asked. That information is actually available and has been done by the European Union and by NASA. So we have what we call solar irradiation, right? It differs from place to place. I'll give you a good example. We did a solar street lighting project in Bayelsa, and it almost failed because the solar radiation in Bayelsa is different from Abuja. But we planned with Abuja, and we had to spend a little more to ensure that the project succeeded. So it goes across all board. Now, for Nigeria, where you have the highest solar irradiation is in the north. Places around Lagos, because of the water bodies around Lagos and all that, it makes it a little bit difficult. You have less solar radiation. Now, for Abuja, it's about 6 hours. Now, like he rightly said, sir, which is very correct, you have to plan on days where you have the solar radiation for the year. So you have times in the year where you have higher solar radiation, let's say 6 hours, 7 hours, but there are times in the year also where you have 3 hours, 4 hours. So the best thing to do is that you plan with the average, that on a worst case scenario, on the worst day, how much are you going to be able to deliver to your battery, and what with your, because you don't want to plan with the best days. You don't want to plan with 7 hours and it's only 3 hours in the year. 3 months in the year that you have 7 hours. So you plan with the worst case scenario, and the worst case scenario ensures that your battery lasts longer, which is very, 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 very important. So it's on NASA. Just go to European Union. If you need any information on that, there's something. The sun really doesn't have a challenge on the efficiency. I can tell you, I'm a practitioner. Yeah, all you have to do, it doesn't stop the efficiency. What actually happens is that it is the light. It's called photovoltaics. It's not the heat that make it bad. The sandstorms it's just a layer. It doesn't really affect it in any way.
Thank you very much, sir. A round of applause for him. Very wonderful contribution there. Solar energy, the next level of energy, renewable energy for ICT. Very insightful discourse. Another round of applause for Mr. Ofor. Very educating. If you have not gone green with solar, you ain't getting it right. So tell somebody beside you, go green, go solar.